Ladies and gentlemen, thank you for joining us today as we are explored the exciting world of embedded systems development with various kind of microcontrollers and DIY projects. In this presentation, we will learn how we can leverage the power of Printf and Scanf in STM32 for C program solutions and to tackle the real world challenges in embedded systems as well as C program solutions. So today we will focus how Printf and Scanf commonly used in C programming and enhance this communication in STM32 microcontroller projects. So why we need printf and scanf in STM32? So here I note 3 points to the applications in STM32. Let's refresh our understanding of printf and scanf. Printf is used to display formatted data on an output stream, while scanf reads formatted data from an input stream. So basically, what we learned, printf is for output and scanf is for input. First, let's open the STM32 So today we will make a live project and we will use printf and scanf in our STM32. And so for microcontroller, I will use today STM32G431KB. For this experiment, I'll make a new project. From STM32 project. Okay, so it's just downloading the cube tools. Okay, finally the prompts. Okay, so commercial part. In my case, I am using STM32 G4 G4 P1 KB. So here I am using the nuclear board. You can see nuclear G431 KB, and keep it. I already keep it star marking. So I select this and click next. So I must keep a name for the project, and so this is the what. Okay. Let me print it. Scan it in G4 because all the projects are same, but my controllers are different. So I must mention the version of my microcontroller because in future maybe I can make mistake. In the project, I must configure the pins. So first, you see, I keep marked on initialize the peripherals with default so that the pin are configured default. Okay. Now this is my UR2. So I just do nothing. This is default LED. Already the pin is configured and already the UR is configured. If I need another UR, so I must configure from here. Connectivity UR1 is at 1. So if I keep it asynchronous mode, so you can see these two pins are for UR1. So now I don't need this actually, but maybe in the next project I will use that. Okay, so I just do nothing. I just generate the code. Okay, so the code is already generated. You can see this is the default code. Let me include studio library because I few seconds ago I told you that we must connect it with the studio.h library. Okay, so I have to write some private user code in here, private user code. So okay, so I already collect the code. You can see the code is anywhere in data. Just keep it here first. Okay, in your case, in my case, you can see this is UR2 for default UR. because by this keyword we can communicate with our computer, our computer by USB. Okay, so I just pasted the code. Okay, and now one more thing, buffering issue with scanf. So if you just only fetch the code and started to use printf and scanf function, so you must face that this function execute with a very small amount of time. This also small amount of time. So printf, the function printf also execute with a small amount of time, but in, the scanf function, until we give any data, it must keep waiting. It must keep waiting for the data comes. If the data not comes, so the program must hold on. So this is the issue. Okay, this is the issue. By to solve this issue, we must use this code. Use this code to stop the buffering issue. Solve the buffering issue. Okay, so at the initialization of our code, user code be input. Okay, one last thing. This is I keep it here. Check the floating point. Check the floating point from setting. Okay, so let's check the floating point. So first go to the project properties and C++, then setting. Okay, then MCU setting. So here these two must be checked. These two floating. So here use the float with printf from newly nano. Use the float with scanf from newly nano. So we must check these two. Apply and rebuild and apply and close. Okay, so now we can now the environment is ready. Okay, the environment is ready, and today we will solve some practice problems. Okay, so basic arithmetic problems we can solve. So as we solve as we solve the problems in code box, you can see where we must give input and then calculate. It's very simple. So basic arithmetic problem, I keep the code here. So I must take three variables if we make sum of many projects. Okay, and just copy and paste it. So first, what will we see? Printf iterative numbers. So we must keep two numbers by keeping space. You can see percentage space percentage. So we must keep a space before entering the number. Then the number, sum of the number, we can see in here serial monitor. Okay, so 32. So after connecting, we can see the storage device. Okay, it's connected. Already downloaded. Okay, so program already flashed and baud rate. So I didn't show you the baud rate in exert 2. My parameter settings is baud rate 115200. Setting on stop it 1. So I must keep finding on 1152 baud rate. So for this I can use the Arduino application, or you can use the other compositor application. No problem. So I'm comfortable with these applications, so that's why I use this. It's open Arduino IDE. Okay, so I must find the comport. So for finding the comport, what I will do, here I'm saying comp 10, 6, and 7, and I don't know which comport which comport connects my STM32. So that's why I unflagged the STM32 and see 6 and 7 are available. So 10 is unavailable. So my comport is 10. It's quite simple. Okay, so click 10. So let's open the serial monitor and this comp 10. Okay, So now I reset the STM32. Okay, and I'm saying that enter two numbers. So two numbers, and first number is 10 and second number is 20, and I am getting sent. So the sum is 30. So the equation, the program is right, and we had no internal buffering issue. Okay, and the program finished. If again I give a number, so nothing will happen. Nothing will happen. So now we can try the problem in while loop. In while loop, because we want to continue the process. We want to continue the process. So let's try. Going to sum again, sum again, sum. Code already last. Okay. So for comes okay. Again reset the microcontroller and two numbers. So I give 45 and 57. Keep send 112, and again it wants enter two numbers because the program just waits here in scanf. Waits here in scanf. You can see if it didn't wait here, so the loop is continuously looping, but it stops here for waiting for the data. Okay, so again I give 45, 64, 109. So you can see the basic arithmetic problems are solved. So it's quite simple. So now so here the float point is float Celsius, float Fahrenheit. Okay, float Celsius, float Fahrenheit, and the copy the code and paste it into the while loop. We can paste the code in the main without outside of while loop and also while loop. If we write the code outside the while loop, it only runs one time, and if we runs the code in while loop, it continuously running. Okay, so I always try to write the code in while loop because in our microcontrollers it must works continuously. So I write the code here. Okay, paste plus the code. This serial monitor I open. Clear. So you can see I opened the serial monitor and plus the code. You can see enter two numbers. But this is the execution of previous program, and this is the execution of newer program. So this is another topic for discussion. So hope so in future we will also discuss it. But today's topic is different, so we must discuss today's topic. Okay. So I clear the topic and reset my microcontroller. Enter the temperature in Celsius. So now today is I think 30 degrees Celsius. So this is the equation. You know, in every students in school, every students when you are in school or college, you must study the Celsius to Fahrenheit equation. So 30 degrees Celsius, I think, and temperature in Fahrenheit is 86.00. So it's just very simple. Okay. So 30.6, 87.08. So it accepts the floating point, float value. Okay, this is good. Now it's nothing, just but a for loop, continuously sum and nothing. Okay, so if we as we are solving the problem, we can solve the problem. Okay, the variables are and sum. Okay, okay. Let's flash. Okay. We reset, enter the number of elements we want to sum. We want to sum phone number. Okay, then enter phone number 4 3, 5, 6. Here I write 4 numbers by keeping an space. Okay. So this four number I give, and sum of the numbers, sum of the 4 numbers is 18. 4, 3, 5, 6. 18. Receive the delay from scanf function, and you can see this is my STM32 G4. This is live fit, and I will also code live. Okay, you can see. First, I keep take an integer. I take an integer delay. Obviously, miss delay miss. Okay. So in the while one loop, forever while loop, I will write printf, enter the time in ms, enter the time ms. You want to print, okay, slash n nil. Okay, then scanf, obviously 6% d because percentage comma address of the delay. Okay. Okay. So again, if I want to so not again, as I want to clean, so I will keep another while on loop, and I will use all GPIO IO toggle. Toggles is very common API for all driver. I will use the default LED. So I just keep my right LED and control space this LED to port. Again L LD LD to pin. Yes, and I take the time from this scanf delay miss. So this all delay. You know this is all delay, and I will pass the delay miss already. It comes. Okay. I just flash the code. Yeah. So it's very common uses. Just wait. Ah, this is done. I will open the serial monitor. Let's open the serial monitor. There is the serial monitor. Okay. And I passed reset because it already comes. Just one time. So just one time. Yes. Okay. So enter the time milliseconds. I want to blink. So first I keep 500. So half second. You can see it just start blinks with half seconds. Okay. Now again I reset. I want to blink it 100 ms. It just 100 ms. Again I'll take it 200. No, 1000. This is 1 second. This is 1 second. You can see. So like this, and I must say this is blocking. This is hall delay is blocking, and every time I want to change the time delay, so I am resetting the MCU. You can see I reset the MCU. But if you want to reduce, if you want to learn that continuously blinks and I can continuously give the delay, so stay with us